All right, welcome again. So in this video, we're going to solve another problem, which is basically we're going to compute the occurrences of every number inside an array. So let's say we have an array here. It's an array. So 2, 3, 1, 6, 1, 7, 1, 2, 3, 1, 4. And we want every number of these numbers, we want to compute how many occurrences we have. For example, for 1 we have 1, 2, 3, 4. So 1 existed 4 times, 2 existed 2 times, 3 existed 2 times, and so on. So the naive approach for this, the most straightforward approach for this, is to basically just iterate all the numbers, and for every number you just loop through the entire array to compute how many occurrences that number have existed. So let's do that. So we have here an index, so let's call that I. And then I will start from the very beginning up to the very end so that we loop through all the numbers. So for I starts at 0 up to n, let's say n is the size of the array up to n. And then we're going to see that number that we're currently pointing at, which is t, let's call the array t, that's t of I. So we want to see how many times this t of I have existed inside the array. Okay, that's t of I. So here's what we want to do. So we want to do, what we want to do is basically we want to loop through the entire array and see how many times it existed. So we're going to say for j is another counter which will traverse the array. So for j starts at 0 up to n, if j, let's close this. So if t of j equals t of I, so if the number that we're currently pointing at by the counter j, by the pointer j, is equal to the number that we want to compute its occurrences, then we have to add 1. Okay, so let's create a counter here. So counter takes 1. So counter takes 1 as an initialization. So we increment that counter. So counter plus plus. Okay, so that's and if, and that's and for. And basically, we want to just print how many number we have. So we're going to print the number t of I have existed counter times. So basically that's how to do it. Okay, so and this is and for. Okay, and what is the complexity of this algorithm? Well, we have an inner loop which has inside it a constant operation. So that's a constant. This is order 01, and we have here an order n operation because we started the counter j from 0 up to n, so n times a constant, that's also n. And then we have an outer loop, so that's an outer loop that is doing its content, executing its content n times. So that's order n times the complexity of the body, of its content. So that's order n times order n, which equals order n squared. Okay? So basically that's the complexity of this algorithm. Now this is the first approach. So the first approach generated a complexity that's equals to order n squared. Yeah. Okay. So let's write the complexity back here. So order n squared. So the second approach is basically to iterate through the array. Iterate through the array. So that's a bunch of numbers. It has a bunch of numbers. So we have to iterate through the array. And we have to create another array. Four, 5, 6, and so on. And the other array will contain the number of occurrences of every number inside the original array. Okay, so this is the original array called T, and then there's another array called occurrences, let's call it ox, which stands for occurrences. And this array gets initialized, is initially filled with zeros. Okay, so every number has occurrences 0. And then we loop through the entire array T. Okay, so for I equals 0 up to n, this will loop through the entire array T. And whenever we find a number inside T, we go to the index of that number here and we increment it by 1. So let's say, for example, we found here 1 and then we found here 1. So we go to index number 1, we add 1, and then we find another 1, so we add another 1, so it becomes 2. It means that the number 1 have existed twice inside the array T. Okay, so for example, if we have here index 3 inside the occurrences array with value, let's say 9, it means that the number 3 have existed 9 times inside the array T. That's how we're going to do it. So we're going to loop through the array T, and every time we're going to take that number, T of I, that number, let's say that's 1, and we're going to go to the index of that number, that's occurrences of 1, and we add 1 to it. So this T of I will be an index inside the occurrences. Okay, so the occurrences of that number gets incremented. Okay, and that's the algorithm. And of course we have to initialize the occurrences to 0 so that we make sure that we're not adding to some random numbers stored in the memory. So let's initialize the occurrences. So for I equals 0 up to max size, very large number, basically the occurrences of I takes 0. Okay? So we initialize the occurrences by 0, and then we traverse T, and then for every number inside T, we go to the index that we consider that number as an index inside the occurrences, and we increment the cell at that index by 1. So that's the algorithm. Now, what is the complexity of this algorithm? You can see that this algorithm has here an n for I equals 0 up to n. Okay, so you can see that this algorithm requires only n operations. This is a constant operation, so this is O1, sorry, that's O1. And then we have that O1 repeated n times. The complexity of the overall algorithm is order n. So from order n squared, we've got an algorithm that works on order n. So this algorithm has a great advantage in time, so it's n times faster than the other algorithm. But there's one minor problem here. If we consider the complexity, the space complexity of this algorithm, we find that for the first one, it is order n, okay? The space complexity is order n, because we used only the array given to us. We didn't use any extra space. But for this algorithm, the space complexity is order n, the size of the original array, plus another array. What is the size of that array? Well, let's think of it in a second. What if the numbers of t could be a very large number? it basically means that we have to have an occurrences array that has that number of cells, right? So the number of cells required by the occurrences vector, the occurrences array, should be equals to the maximum number inside the element of T. Okay, so the complexity, the space complexity of the second algorithm would be order the maximum element inside T. Okay, so if the maximum element happens to be n, then we need just an occurrences array of size 10. If the maximum element is 100,000, then the size of the occurrences array would be 100,000. So this algorithm is horrible in terms of space for very large values inside the original array. It'll be very efficient, for example, if the array was a string, because we know that every character could be from 0 to 255. That's the ASCII table. So at max, we're going to construct an occurrences array of size 256. But for integers, it depends on the values of T. Okay? But if space doesn't matter, then, and time is the only thing that matters, then it's faster in terms of time. There's also another way to, so here we lost time to win space, and here we want time to lose space. So there's another method in between to solve this problem without losing so much time and without losing so much space. Okay, so it's a method in between, which is basically to follow the same algorithm here, but instead of storing the values, instead of storing occurrences of T of I inside a regular array, we would store that in a hash table, and we're going to see hash tables in data structures. So I want you to know that that idea exists. Okay. So thank you for watching, and see you at the next video.